works here. Michael? This is the original function. I'm trying to get a sketch of it. It's not polynomial. It's not going to be a nice smooth graph. All right, now I found the domain to be this. I rewrote the original function. They asked me to. X-intercept, we found it. Y-intercept, we got it. So at least we have the X and Y intercepts. Now, as it goes further on the steps to follow here, I have to slow down and sort of explain what on earth are they asking. What's, I think step 4 maybe? What's the next step?
Determine the vertical asymptote.
Yeah, this. There's something known as this. Vertical asymptotes. And if I look at that, I use a professor, what are they asking for there? What a vertical, I know what a vertical line is. The vertical asymptote. Now back on my most basic graph. You see this vertical line? Was my graph short enough getting close to it, but did not touch it? So this could be acting as the vertical asymptote on my most simple graph that I graphed over here, 1 over x. So its vertical asymptote is 0. X equal to 0, or the y-axis in this case. They're asking now, on this one we're attempting to graph now, this thing, where is it located? Here. And how can I find out for sure where it is located? Okay, it's called a vertical asymptote. Guys, by the way, is my graph back here, my most basic graph, 1 over x, of course x cannot be 0. Maybe that's a hint as to where my vertical asymptotes may be. Here, x cannot be what, I think? He said what? Plus or minus 2. So it might tell me, based on the other graph, that maybe out at 2, in fact I haven't started graphing this thing yet. Out at 2 and negative 2 are vertical asymptotes. I'm going to list them like this. X is equal to 2, x is equal to a negative 2. Michael, just out of curiosity, did I give the students a plan, something to do to find?
It says no, set denominator to 0.
That's all you do. Set the denominator equal to 0, solve it, and I'll quickly tell you when you get to the graph where those vertical lines are located. And they're called asymptotes. Vertical asymptotes. A vertical line that you cannot let the graph touch. By the way, suppose it did touch. What could you say as a good, clever student? No, professor, I made mine touch the vertical asymptote of my quiz, and automatically you get all your points taken off. Why? Please, someone tell me. Why might I not be able to touch, let my graph touch? It can get close, but cannot touch that vertical line. What's the rationale behind it? Like when I get to this one, I cannot let my graph touch. When I draw the 2 vertical lines at these 2 spots, I cannot let my graph touch those 2 vertical lines. Can anyone give me a good rationale? Why can I not let the graph touch? Because if I let it touch, x becomes 2. If x is 2, what happens if I take x to be a 2 back here and put it in? You get a 0 denominator. That's undefined. That's why at 2, when I finally get to my graph at 2, I cannot let the graph touch 2. And I cannot let the graph touch the vertical line at negative 2 for the same reason. Replace x by negative 2, you get a 0 denominator. You can't have that. That's the rationale behind it. But at least we know how to find it. Number 5, now, here we go. And on this particular problem, I may just stop at number 5. Michael, what's number 5 asking?
Determine the horizontal.
Oh my goodness, hang on. A horizontal asymptote, not vertical, not a vertical line, a horizontal. Is there a horizontal asymptote on the graph of this function that I finally start graphing? Back here, guys, on my most basic graph, 1 over x, is there a horizontal line somehow playing a part here? In this case, I think it's the x-axis. Is the x-axis a horizontal line? And is my graph touching it, or is it getting close to it? I think that graph is showing what? If I take that graph this way, is it getting close to the x-axis and did not touch? On the other side, the red graph this way is getting close to the x-axis, which is a horizontal line, right? It's acting as a guide for the graph. Now, can I find the guide for the graph of this thing? And how can I find it? Does anyone have an idea? In fact, I'm gonna have Michael read what I suggested on the handout. I thought maybe I would throw it out and see if a student would say, Professor, I think I see a way to find where the horizontal asymptote is. Right quickly, and you draw that horizontal line. Okay, Michael, read us what you're asking.
The horizontal asymptote will describe end behavior of the function.
Whoa, I want the end behavior of the function. Who said, Professor, it depends on the first term. No, that's for a polynomial. That's how you find the end behavior for a polynomial, is look at the first term. What on earth is the first term here? You can't do it as easily as you could a polynomial function. It has no so-called first term. It's a fraction, it's a mess. So I need to come up with where are those horizontal, or the horizontal asymptote located. I think I had read more though. Read more, or I had more on there.
To find it, we'll use the end behavior of r of x equals 1 over x.
Hold on now. Guys, please tell me. Here we go. Suppose I ask you to find the limit as x is approaching infinity, which I think we may have done already, for 1 over x. Did we say if you make x get large, and I think I did something over here earlier, as you make x get large, 1 over 10, 1 over 100, 1 over 1,000, 1 over 10,000, are those values getting smaller and smaller and smaller? Are they approaching 0? You could also think in those terms to answer this one. What's the limit as x is approaching negative infinity on the other end of this function, 1 over x? Now you replace it by a negative number. Do you think also it'll be approaching 0 even on that side? Now, this has been established. He's telling me to find the horizontal asymptote on this function, to do something and make use of the knowledge of this. That's called end behavior. Now, what am I going to do? Watch carefully. Watch carefully. I asked my student who sent the information to me from his calc course he's taking now at the university. I said, how are they teaching this at your calc, in your calc class at that university? How are they teaching this? Because I've shown students a shortcut. I mean, a real shortcut where you find where the horizontal asymptote is going to be located in no time. And then I've shown some classes the longer, convoluted way, going back to this 1 over x. He says they're using 1 over x. They're not using a little shortcut, Professor. They're using the 1 over x. They're trying to make use of this knowledge to get the horizontal asymptote on this one. Now, this is what they're doing. They're saying, please take your function on the side here. Guys, this little process. That's x minus 1 over x squared subtract 4. Look at the numerator, look at the denominator, and tell me what's the highest exponent you see as you scan through both. What's the highest exponent you see? 2. They say, now, it's just a little process. Now go through and divide everything in red there by x squared. That's the highest. Always divide by the highest. So make this x over x squared minus 1 over x squared. This is the way they're doing it. X squared over x squared minus 4 over x squared. First, you determine the highest, then go through and divide everything by it. A little process. Then you simplify as best you can. I know from algebra, x over x squared is the same as 1 over x. Which takes me back to this. That's why they're asking you to do this little process. We'll take you back here to the basic graph. 1 over x squared, you get back there. Please rewrite that 1 over x squared as this. It can be expressed as 1 over x times 1 over x. That takes me back there. the denominator, x squared over x squared definitely is one. Now, this strange fraction here on the end, 4 over x squared, to get back there to 1 over x, please rewrite it as this. 4 times 1 over x times 1 over x. You're trying to get that 1 over x in there as much as possible. Why? What was the end behavior answer for this one over here? 0. So wherever I see a 1 over x back here in this little process, I get to put a 0 in there. We've already established that back here. The limit as x is approaching infinity for 1 over x is 0. And negative infinity, 0. So I get to do this. I get to put a 0 here, 0 here, times 0 here. Gotta leave the 1 the way it is. 0 here, times 0 there. Everywhere you see a 1 over x, you can put a 0. Based on this. It's been established earlier. And then cleaned up. And guys, on top, there's not much to clean up, it's 0. When you do the math there. In my denominator, 1 subtract, well, 4 times 0 on the end is 0. That drops out, and all this drops out. I'm left with 1. And 0 divided by 1 is 0. All that effort tells me my graph, and if I get to it and start graphing, its horizontal asymptote is also 0. Which means y, I'm gonna call it y is equal to 0. Is also the horizontal asymptote at the x-axis. It's called x-axis. So the x-axis is also acting, after all this work, as the horizontal asymptote for the graph, which we don't have yet, of this function. Whew. Oh, I'm glad we're going to get this out of the way, because it's madness. Now, Michael, challenge last what else is right there close by, something else to be worried about on that horizontal asymptote.
It's possible for that to intersect its
Oh.
horizontal asymptote.
Oh, here we go. It did not happen on 1 over x, this one. If, guys, look at this. This graph right here could have, it didn't, no. It could have, in some cases, come down, like this, and intersect, and then follow underneath it forever, stay close to it. But now it's underneath it, it's crossed over. It's called a crossover point. But it's still going through infinity. It's going to stretch out forever, except it's dropped down below, and then follows the x-axis. It's called a crossover point. Woo! Did I give any hint on how to find the crossover point?
No.
No. Does anyone have an idea? Does this thing right here, when I graph it, and this is the last part when we start graphing, does anyone have an idea of how to find, if there is one, is there a crossover point? Right like this. Is there a crossover point of my graph with the horizontal asymptote? Anyone tell me a clever way to find, is there a point of intersection? If so, I've got to show it. Does anyone have a clever way to do this and find it, and we'll start graphing? I do know they may not intersect. My basic graph did not. Any ideas? The function with its horizontal asymptote. Let me rephrase it. When are they the same, if they are the same? How would you find, what would you do algebraically to find? When are they the same value? My function and the horizontal asymptote, which we said was 0. What would you do to find that? When is my function equal to 0? Okay, I'm going to look for it, well, sort of like an intercept. For the crossover point, guys, I'm going to set my function, which is over here, equal to, and we discovered, where is my horizontal asymptote on this one? Is it 0? Okay, so when are those two equal? And that means to find it, if there is one, set the function, what is it, x minus 1 over over x squared subtract 4, set that equal to 0. We're going to set the function equal to whatever the horizontal asymptote, in my case, 0, set them equal. You see, at what point are they equal? And that's where it should cross over. If I do a quick cross multiplication, please help me. Do I end up with x minus 1 is equal to 0? If I multiply both sides by x squared minus 4 or do a quick cross multiplication. Therefore, I end up with x equal to 1. That's going to be a crossover point. What's the full point? X is 1. And it should be on my horizontal asymptote, that's true? Which came out to be, what was my horizontal asymptote here? Where did all this work? Was that 0? There's the full point. X is 1, 0. Okay. Michael, go ahead and read the next part, but I can't get into that until Wednesday. Let's just read it. Is it this the oblique coming up? We gotta stay away from the oblique tonight. That's what they're gonna do, a lesson altogether. Now, I'm hoping I have enough right here to graph this. Based on what you see here, this would be the first, for some of my students may have seen these rational functions before. I'd like to see what on earth, put all this together, Professor, what is the graph? Let me find it. Here goes. I'm gonna try to use as many different colors as I can here. Let's go back. Number 1, got the domain out of the way, that's no problem. Number 2, we simplified it, no problem. X-intercept, oh my goodness, the x-intercept came out to be 1, 0. And then all of a sudden we found out things of what? Crossover point? That's strange, it's also 1, 0. Mark this. Out here, I'm going to mark this, the x-intercept is here. Guys, this is the first that some students have seen for a rational function. Be careful. Y-intercept, I think I found it somewhere. Oh, 0, 1/4. Up 1/4. We mark 1 for a reference. What's 1/4 right in there? Place it there. So I got 1 for an x-intercept, 1/4 for a y-intercept. Michael, you're telling me also I could place on that graph, where am I? We have 2 vertical asymptotes, 2 vertical lines, out at 2 and -2. We place those next. 2, -2. Now guys, I'm gonna place these in red for a reason. You cannot let the graph touch these lines, these vertical lines, vertical asymptotes. Mark mine like this. There's 1 at 2. There's also 1 at -2. Horizontal asymptote, I think we check and see if we have it here. We do horizontal asymptote. We discover what, the x-axis? Do all the x-axis, let's put that in green. That's acting as my horizontal asymptote. My horizontal line. Line is up. Like that. Oh my goodness. Looking back, I think I've used everything up. I think. If I use everything, vertical asymptote, horizontal asymptote, crossover point is 2. Next said, Professor, where's the graph? Where is the graph? Oh, I wish this was a polynomial function. It's not. I said, Professor, where is it? It's disconnected. Now, based on these red vertical asymptotes, the red vertical lines, that tells me there's a piece of the graph out here somewhere. And it's disconnected from, there's a piece in between for this crazy graph. And disconnected from, there's a piece to the right. I think, based on what I see here, I think I can sort of see the piece in between. Because in between, you got to pick up the y-intercept and that x-intercept. And you gotta show the graph gets close to those vertical lines, asymptotes, but you can't let the graph touch. Now, see if, since this is the first one you guys have seen, see if this is reasonable. I'm gonna get close to those red vertical lines, asymptotes. Pick up my X and Y intercept. And it's getting close to the red. It comes on down, picks up the Y intercept, picks up the X intercept, and goes on down and gets close to the other vertical asymptote. Is that reasonable? Pick up the X intercept, picked up the Y intercept, gotta pick up those intercepts in between, and make the graph get close to those red lines, but do not let the graph touch. Is that reasonable? Now, guys, out here to the left, I don't have any points to connect. But I know there's a piece of the graph out here somewhere. Can anyone give me an idea of what would you do? You're getting a little desperate here. There are no points out here to connect. You've got forms and points yourself. What would you do to see sort of, where is that piece out to the left of this red vertical asymptote out here? Where's the graph located here? Or what does it look like? What would you do? Give me an idea. See, I knew you want to slow down when you saw rational functions. They're not nice to work with. What would you do to discover where's the piece out to the left of -2? I'm gonna plot a point. I'm gonna plot a point. That guy's out to the left, maybe -3 or -4 or -5. Lots of numbers out to the left of -2. I'd like to know what's going on out there. Guys, I'm gonna go back real quick. It's gonna be easy. And I'm gonna find, here we go. Right here's my function. I'm gonna find R at -3. I'll stay close by. I'll just replace X by -3, find the value. I'll end up with -4. Replacing by -3, here will be 9. 9 subtract 4 is 5. So -4/5. So it says go out to -3, right here, on your function, and drop down -4/5. So is the point somewhere in here? About -3, and therefore that one point tells me, Professor, I have no choice. If that one point that you created is right here somewhere, and I gotta still follow the green and the red, I've got to still follow the green horizontal and the red vertical, so I have no choice. It's gonna look something like that. There's the other piece. Now there's one more piece of this discontinuous function. Out here to the right of 2, there's something going on. I've plot a point. Out at 2, let's try 3, +3 this time. Let's find R at 3. Just point real quickly. Replace X by 3, guys, we end up with 2 over, I think I did it quickly, 2 over 5. Is that true? Let's try 3. Replace 3 in my function. That says out at, what was it, 3, right here. You move out 3, and in this case, up 2/5. So out 2/5, what's this up in here somewhere? Up in there, just real quickly, out 3, up 2/5. Is that true? Now, can anyone tell me, based on that one point, I don't have much choice. It's still got to follow the red and the green. The red and the green. Those asymptotes. I don't have much choice. I gotta get close to the red, can't touch it. Close to the green, the horizontal. There's the other piece. There's your first, from me at least, example of a rational function. Now you gotta put some thought into this. I mean, big time thought. And I haven't even mentioned oblique asymptote. Vertical and horizontal is all I'm sticking with today. Okay, guys, the graph looks like that. Okay, here's a few questions. We'll accept this as a graph. A few questions here. Can someone tell me the limit as x is approaching infinity of this function, I'm just call it r of x, based on the graph. That means you're making x get large. That means on the x-axis, you're walking out this way, you're going to drag this blue graph along with you. But you're walking out this way on the x-axis forever, and taking that blue graph with you. How's the blue graph behaving? What's it doing? What do you think it's doing as I drag this blue graph along with me in this direction through infinity? Is it getting closer and closer to the x-axis, which is acting as 0? The other end, it's like end behavior, limit, as x is approaching negative infinity of this function. Same process, you're going to walk this way to the left, drag this blue graph along with you as you drag it along, walking this way forever along the x-axis. What do you think it's doing, or how's it behaving? Is it also going to get closer and closer and closer to the x-axis or 0? But it's underneath it, but still getting close to 0. Way out there. Right here is the answer for those two. Now, I'm going to be clever. I'd like to find the limit as x is approaching 2 from the right of this function. 2 from the superscript positive sign, 2 from the right. I see 2 on my graph. It says now visualize coming in, stay on the right, coming in and get as close to 2 as you can, but stay on the right. That's what this means. Approaching 2 from the right. What's my blue graph doing? The closer you get to 2, you can't go over 2. You gotta get close to 2, stay on the right. What's my blue graph doing? Is it doing this? The closer I get to 2. Positive infinity. Rising. Let's try one more. Number 4. Find the limit. As x is approaching, let's try negative 2. Negative 2 from the left of this function. As it says, stay on the left of negative 2. Approach it though, but stay on the left. And it looks like, we'll try green. We'll stay on the left. Coming in toward approaching negative 2 on the left. What's my blue graph doing the closer I get to a negative 2 and I stay on the left? Is it dropping down through negative infinity? Wow, wow, wow. Michael, please tell me, is that just the first problem?
Yes.
How many did I have down there?
4.
There's no way. We just got the first one done. Let's see if I got it here. We got 4 times, of course. But right now, look how much time it took me just to do this one problem. We've got the graph. I took a look at a few limits. Let's see if I can do something else. Oh, I could. Could someone tell me, based on what you see up here, I'm going to have Mr. Park to confirm it. Suppose I ask you, here's my function, suppose for some reason I want this. What's R at 50? You say, Professor, you're gonna make me replace X by 50 here? I could. 50 squared is not too big of a number, I could, and crunch it out. Can someone tell me, based on the graph itself, by the time you get out to 50, out here, I got 50. What's my blue graph? How's it behaving? What's it close to? 0. Is it close to 0? Because this is close to 0. Just based on the graph. If you want to put 50 in there and crunch it out, you'll see it's a small, small number coming out for an answer. Close to 0 though. Wow. Michael, I'm looking at my time here because I want to do something else before we close down. Get more hints on that quiz on. Let's see if I can turn up that quiz. Let's see if I'm ready. I think